Hi, I'm Dr. Anthony Maxon, and I helped to develop the PupilScreen smartphone pupillometry application for Aperture. In this brief video, I would like to describe how our PupilScreen platform leverages cutting-edge machine learning and artificial intelligence technology to deliver neurodiagnostics via next-generation pupillary analytics. The use of the PupilScreen solution is covered in a separate video, and I welcome you to watch that video as well if you have not already done so. In terms of machine learning and AI, PupilScreen currently leverages a triple-pronged approach. The PupilScreen platform begins with the recording of an 8-second video of the pupillary light reflex. Once captured and submitted for processing, our computer vision machine learning model is used to detect the pupil diameter for each eye throughout every frame of the PupilScreen video recording. There are a variety of different methods for training computer vision models such as ours, and we chose one of the most thorough. Our computer vision machine learning model was trained on over 1,000 PupilScreen recordings. During the training process, the pupils in each frame of these recordings were hand-labeled by the Aperture team to ensure the greatest ground truth accuracy for our computer vision machine learning model. Once this was completed, we trained a state-of-the-art computer vision model on this labeled data. Our training produced a computer vision model that is 98% accurate in detecting the pupil diameter throughout any PupilScreen recording when compared to the ground truth labeling of the pupils. The benefit of our approach is that the PupilScreen becomes more and more accurate in pupil detection with every new recording that is taken. Now that I've explained our computer vision machine learning approach, I'd like to talk about how PupilScreen becomes a next-generation neurodiagnostic tool. For the past 100 years that pupillometry has existed, using a pen light or other light source to look into a patient's eyes, and for the past 20 or so years that quantitative pupillometry has existed to outline the pupillary light reflex diameter curve, there has been little diagnostic potential. Here at Aperture, we believe that there is more power in the pupils than simply to monitor for brain herniation in patients with severe traumatic brain injury. To accomplish this, we take a holistic approach to pupillary analysis, looking at the entire pupillary light reflex curve and its multiple component parts to arrive at an accurate, sensitive, and specific determination of brain health. The PupilScreen platform currently leverages machine learning classification algorithms to bring the cutting edge to pupillary analytics and to allow for such previously unheard of pupillary diagnostic applications as diagnosing concussion, Alzheimer's disease, vasospasm, fatigue, and neuroperformance levels. PupilScreen learns which unique sections of the pupillary light reflex curve, such as the baseline diameter, percent change in pupil diameter, latency of pupillary constriction, velocity of pupillary constriction, and velocity of pupillary redilation, are most affected by each of the aforementioned conditions, and more. With this knowledge, PupilScreen uses machine learning classification algorithms to produce diagnoses that are sensitive and specific to brain health conditions. At Aperture, we are working towards the development of a vital sign for the brain via the PupilScreen platform. What this means to us is a comprehensive diagnostic and monitoring tool that is used right after the blood pressure cuff at every visit to the doctor's office. If you were wondering where the AI comes in after all this time spent talking about machine learning, here it is. The PupilScreen platform utilizes recent advances in generative artificial intelligence and large language models to analyze our database of pupillary light reflex curves associated with a wide variety of neurological conditions, including concussion and Alzheimer's disease, that are collected and verified by clinicians at our research sites around the world. During training on our large database of pupillary light reflex curves and clinical data for brain health conditions, PupilScreen AI learns nuances in the pupillary light reflex curves, as well as clinical data collected at our research sites to produce a diagnostic model far more powerful than can be accomplished by use of current traditional machine learning techniques. The result is a comprehensive vital sign for brain health. PupilScreen AI not only tells you about your brain health today from a monitoring perspective, compared, for example, to high-performing individuals such as elite athletes, it can be prompted to interpret your pupillary light reflex curve as you recover from a concussion, or as you are monitoring the cognitive status of a loved one with mild cognitive impairment at risk for Alzheimer's disease, for example. With PupilScreen AI monitoring brain health whenever needed, the future is truly limitless for both personal and professional use. All in all, I hope that this explanation has been helpful, and on behalf of Aperture, I appreciate your interest in and use of PupilScreen. Thank you.